everyone, and welcome back to another Math Research Live with me, Charlotte Aten. So today I have a couple of different new things for you, and also it looks like my dog wants to say hi. Hey, doggy. Yeah, he needs lots of attention, of course. The second that I start doing this, it's like I want some of that attention. All right. I'm going to have a pretty cool stream for you today. So I'm doing something which I've never done before, which is live coding, which I guess is maybe a more traditional thing to do while streaming. And so I'm finally going to do that. If my dog will let me. Are you good, buddy? Okay, he's very adamant that you want to be part of the stream, bud? Come on. It's okay. Yeah. Okay. All right. No, he's ready to play now. All right. That's fine. So so I'm going to be live coding, and in addition to that, we also finally have a channel emoji. So or the sticker or whatever it is. So so make sure that you try it out at some point. So my partner made this, and they actually have a Twitch channel as well, and do various art things. I maybe will include a link to some of their stuff in a video description, and maybe I'll also post a link in the chat. Let me see. I actually had put this link somewhere else before, so I should be able to find a copy of it. Okay, so let's see. What's going to be the easiest way for me to find this? I should have thought of this one first. That I'd want to send a link. Actually, maybe I can just at them in the interface. Is that going to be possible? Is that no? Okay. Well, okay. Let's see. Oh, you can see what I'm typing there anyway. All right. So let's see if I can find a good link to give you, so that I make sure I'm giving you the correct thing. I'm just going to copy a link that I posted on Mastodon at some point, and hopefully that'll be good. I've posted so many things on Mastodon though. Oh, I found it. Okay, perfect. Let's see. So the fact that Firefox has, I just went to copy this from my post, and the fact that Firefox has something that says copy link without website tracking is just a real commentary on the sad state of things these days. But all right. So anyway, there's their link to their Twitch. I also have a link to the paper that that this code is going to be related to today. So maybe if there are questions, I'm happy to show you parts of the paper or whatever. But I'm going to try to do some work on the code. Let's see. And so, don't be shy. Oh, yeah, thanks. Yeah, absolutely. So they did a really great job with the Genus 3 donut, and it is like an actual donut that you can eat. I mean, at least it's an artistic depiction of one. And it's going to be pretty cool. So feel free to, if you have enough points in the gamified system here, feel free to use the donut emoji. I'm actually not going to be talking about something that's super topological today, but oh no. Yeah, please be careful. It's just a depiction of a donut. It's not an actual edible thing. But yeah, in the very first live stream I did, I said that this was going to be a thing, and it is a thing. We have a Genus We have a genus 3 donut, and get it while it's cheap, because later on we might have genus 1 or 2 donuts, and they'll cost less points, and this one will get bumped up to being more expensive. So while you can, make sure to take advantage of the discounted genus 3 donut. Toppings, maybe the extra toppings will, cost extra, of course, as everything does these days. But, all right, great. So, hopefully someone will try it out at some point. I'll maybe let one of you be the first one to try actually using the emoji. But yeah, that'll be cool, and hopefully we'll have more stuff like that coming up for you as the summer progresses. Okay, so so I linked the paper. I linked my partner's Twitch, and also I realized another thing I would like to do is the paper has a link to the code as it currently is on GitHub, but I figure I'll actually send you a link in the chat as well to let you just check out the code at your leisure. So that's the GitHub repo as it currently is, and I'm actually going to be working off whatever the state of that is at the moment. And as always, even though I'm not maybe going to regularly be at the whiteboard today, unless I need to go back and figure something out in the whiteboard, just feel free to ask me anything about the paper, about what I'm working on, and I'll be happy to answer your question and even draw pictures if it's helpful. So just don't be shy, just jump right in, and I'll be happy to talk about that. I can do a little bit of the the drama and the politics surrounding some of this stuff too with machine learning. It's still at the moment a pretty hot topic, but I won't want that to be the whole time. So if you have questions like that, I'll try to give you a reasonably succinct answer, because that can be a whole thing in and of itself. All right, cool. So so where I'm at the moment is so when I was getting ready to do this stream, I realized that actually since the last time that I'd worked on this project on this computer, it happened that I actually let's see, maybe this will be better. No, you can still see pretty much all of it if I do that. Can people actually read the code at all, or is this too small? Do I need to go in and change my settings? What do you think? Is this legible to people? It's fine? Alright. Well, okay. So, seems good. Okay, so, well, I realized I hadn't actually worked on this since I had reinstalled my operating system. So what happened at some point is that I was not afraid of system upgrades as much as I should have been, even though every once in a while I'll get one where they messed up the driver support and now there's something wrong with the display or something like that. Every once in a while it would happen, but it was only every few years, and so it was never enough of a problem for me to be like, oh, I should just stick on a stable release, that's going to have long-term support, and then just, wait to upgrade at some point. So I would always just say, oh yeah, sure, I'll upgrade as soon as the upgrade's available, And finally, I ended up getting one that somehow borked my wireless card, and so then I ended up having to go through this whole reinstall to try to get it to working again, and then I forgot that I hadn't actually worked on this machine since I did that, and I was like, oh no, I have to get, with 15 minutes to spare, I have to get PyCharm reinstalled and all of this, and then I realized I had a portable install on this computer, so that was actually quite easy to get going again. I haven't tried running stuff again, but it seems like my environment seems okay, hopefully, fingers crossed, and I was able to pull, and that all seemed fine, so I think everything's okay. I think that this may actually be good. So this file I'm looking at right now is just a bunch of basic definitions for just setting up a neural net in general. What is this? What is this? One error? What is this upset about? Oh, no module names numpy. Okay. All right. So that probably has to be installed since I just started. Oh, okay. Since I just reset this up. So yes, please do that. Okay. All right. That's fine. Yeah, I thought I actually had a virtual environment, so let's see if that's happy. This is, of course, 90% of coding is configuration. Let's see, is it doing something? It seems to be updating. Alright, well, let's try to run it and see what happens. Alright. And then if it gets angry, then we'll know what's going on. Yes. Alright. So I told it I wanted to configure and it did nothing. Okay. Did it open a different window? No. Alright, fine. Let's experience whatever is going on here. Settings. Alright, so now I do have a virtual interpreter set up. Usually it doesn't force me to do this manually, but who knows. In the past, I was able to just have it do this for me into the virtual environment without any problem that I can recall. So let's see if, oh, okay, here we go. It looks like it did it and was happy about that. So that's quite encouraging. Alright, let's try this again. This shouldn't produce any output. Okay, are you still going to give me the red squiggle for the rest of all time? Even though, oh, no, okay. Alright, sick. So now at least it seems like everything's working. This module just defines a bunch of things related to the general neural net setup from that paper, so it's not really supposed to produce any output. But let's at least go through and see if we can successfully maybe, just run all of the source modules, which again shouldn't produce any output. But if I'm having, okay, yeah. So let's see. Okay, so here's where I'm going to have some work to do. So I've been working with a bunch of students for years at this point. It's called Tripods 2021 UA because the project started in 2021 and it's ongoing. There's at least one paper that should hopefully be published in the not too distant future that I'm making edits on right now, which is the one that I linked, and then there's another paper that's forthcoming. So it's an ongoing project, and we just re-implemented some of these dominion polymorphisms that are defined in that paper, and so the old code did this, but the new code actually has its own definition for that somewhere. And so now my job is to make sure that I'm integrating this correctly. So if you see my current branch, I called Dominion Merge because one of my students has implemented this and has made some changes that incorporate these things. But now it is my job to figure out how to actually make sure that everything's working together because there's still some additional steps to fit it into the whole big picture. So let's see. So this one actually isn't gonna run even though it's just defining things because there's import issues. So maybe I'll have to come back to that. So that actually needs work. Let's see. Alright, I don't care for this. I don't care for this annotation. I know that there's classes because it says classes there. Okay, this wants matplotlib. Alright, are you going to complain to me about trying to just ask you to install it? Alright. I click configure. It still does nothing. Alright, I'll just manually do it in the settings again because why not? There must be something going on with PyCharm, because like when I do it, it looks like it's just doing it into this virtual environment. So I don't know what the big problem is, but we need matplotlib if we want to draw pictures. So there it is. There's always something else. And so in math, you know, it's like remembering like all the definitions and setting up your notation and everything. But when you're coding, the analogous thing is environment setup. And environment setup is just there's you know, people have 1,000,001 solutions, but there's not really a solution because every solution brings new problems. And it's just life. So for me personally, I think the trick is to actually just try not to worry about it too much, and just, you know, just do whatever you can to keep things simple, and just, you know, just try not to stress too much about it, because if you really try to make it perfect or try to automate it too much or whatever, you're just doomed. And you want to actually get to coding and not just fiddling around with the environment. So, you know. Oh yeah, if code is underlined, if there's a complaint, you just comment it out. Problem solved. It's just that simple. You know, if you comment out the entire module and then you run it, you won't have any errors whatsoever. It'll be perfect. Okay, so let's see. So we have all this. This should probably. Oh, what is this? If not, what do you think? What do you think? Okay, I'm gonna reformat. What don't you like? Oh yeah, the donuts, yes. Thank you. Thank you, Isaac. 09809. Yeah, great. I'm glad that they work. They look good. I definitely should use this prominently in any marketing that I do from now on. Because like in the more detailed picture, you can see like there's like really fun like sprinkles and stuff, and it's really cool. There's only so much resolution you can get on the Twitch emojis though, so yeah. But maybe if you squint really hard, you can see. All right. Well, it looks like this was able to evaluate. I don't know why it's upset about this not invert. Okay, it wants me to invert if condition. It wants me to say are you going to be happy if I say is not in? Okay. All right. It felt better about that apparently. Fine. Whatever. All right. What is this? What are you upset about here? Literally nothing. Alright. Yeah, okay. No need to check partial row entries. Alright, so this is gonna be a big part of what I actually need to work on here. So okay, so this I'll have to deal with. What are you angry about? Oh, do not assign a lambda expression. Okay. Where did that happen? Oh, that's what you're upset about. Okay. Yeah, I guess. Alright, well we'll take a look at that. One of my students wrote this, so I'm gonna have to take a look at why we're actually returning. Oh, okay. We just need to pass a lambda. We don't actually need to say that there. Will it be happy? Yeah, okay. It's fine. We just need to pass the lambda. I'm really glad that there's the code format thing in PyCharm, because like I get like really obsessive in languages that don't have like enough conventions that it's forced on you. I get like really obsessive about the spacing and organizing everything, and like I mean I sort of have my own additional conventions for Python as well. Oh, hello. Yeah, thanks for joining us. So, you know, I have some of my own additional conventions for Python as well, as far as like how I do doc strings especially, but like the you know, auto formatting for the spacing and stuff it really helps me to be less stressed out about like being consistent, because like I have this like need for everything to be perfect, you know. All right, well, so I'm going to be fiddling. It seems like this is what I'm going to be fiddling around with a lot. Let's see what it looks like in some of these other ones. Okay, so this, so yeah, speaking of formatting, I guess this has some formatting that it's displeased with, so I'm gonna have to check on this one as well. Although, let's see. You know what actually would be helpful is that I'm gonna actually. This project, so this originally started in 2021, so this is year, you know, I guess, well, it's coming up on 3 years that this has been going on. So I was at the end of grad school when it started, and I'm moving on to my second postdoctoral position soon, so it's been going for a while, and even after the pure Python version of this is finished, yeah, it takes time, you know, doing things well takes time anyway. So after the pure Python version of this is finished, my long-term hope is eventually to have maybe some libraries, start writing some libraries in C that will, you know, make the more computationally intensive parts of this faster, and see about speeding it up. But you know, the first thing is just to get it done in Python as a proof of concept for the general idea, and then, you know, if it really is worth it, then I'll start trying to actually get better performance. But yeah, it's been a really great learning experience. Oh yeah. So yeah, I mean, I do really encourage you to do, you know, to do. You know, do math yourself too, in addition to just watching people do it. It's easy to watch people do it and then say, oh yes, I understand that, I totally could have figured that out. But it's different when you're the one who's actually explaining it or having to figure it out, you know, without just listening to someone else do it. Oh yeah, so I just kind of jumped in just to kind of get going on something. Yeah, so as far as like the overview of what the code does, actually what I was gonna do is I was gonna pull out the README, which I'm also gonna use as a little bit of a guide for me to follow, to figure out like what I need to work on, because this has become quite complex. Yeah, so what this is doing is this code is implementing the general setup of a neural net just from scratch in Python, and in particular the preprint that I posted in the chat earlier, that's pinned in the chat, it's doing what's described in that preprint. So it's a neural net whose activation functions can just be arbitrary functions. They're not specifically, you know, some, you know, the composition of some, like, you know, sigmoid function or something with, you know, taking a dot product with some weights or something like that. They're just arbitrary functions. And then what we actually do is restrict down, instead of to that class of continuous, you know, or smooth functions or whatever, we restrict down to a class of discrete operations called polymorphisms, which have certain, like, theoretical reasons why we believe that these should be superior in certain ways for doing learning tasks. And you know, we have some simple evidence of this, which, you know, has come from this thing, but now we're trying to get it a little bit cleaned up and get some nice, you know, examples some nice examples coming out to hopefully maybe add into the paper that I'm doing edits on right now. And also, you know, it's kind of an ongoing project. There's another paper that's in the works as well. So better actually means, well, okay, before answering what better means, so as far as should you follow along, how accessible is this to someone with only a little computational algebra experience? So, I mean, I think this is going to be pretty followable. Also, like, you'll be able to see some of the results regardless of understanding how any of the code works or anything, because, you know, I'll be able to show you, this is the output, okay, it seems like that makes sense, and, you know, yeah, so, I mean, if you're interested, you can definitely check it out, and I'm always happy to answer questions about just, like, what is this doing? I'll even draw pictures if you want, but I figured I'd just start to kind of get into this again, dust off the cobwebs, and hopefully this summer, one of the things that I'll spend some more time doing is getting this, you know, making more progress on this again. So I hope, you know, just let me know if you have more questions, or if there's a specific thing I can clarify about, you know, making this more understandable. So the question about does better mean converges faster or something else? So better means, like, the initial motivation for this is basically that, I mean, there's sort of a little more to it, which I'll skip, but the one of the main, you know, selling points of this is that if you have a traditional neural net with the setup that I described previously, where you have, like, say, a sigmoid function and you compose with a dot product, and you just do the traditional neural net setup, you do gradient descent, you know, like nothing fancy, then there are early mathematical results in the area that say basically, okay, if you want to model any continuous, you know, any smooth function, whatever, you basically can up to an arbitrarily small error using one of these things. And so that's not necessarily a proof that you will reasonably be able to learn everything. There's a little more detail to it than that, but at least it's conceivable that possibly a neural net of that type could represent any function. That is one of the first types of results that people proved about neural nets, and that's, I mean, that's kind of nice in the sense that that means that you can, you know, you could conceivably have it, you know, learn in the sense of representing any particular function that you wanted. But that's also bad because if you can represent any function, then you can overfit, and you know, that's a fundamental problem in the area. Let's see. Oh yeah, I see. Thanks. Yeah, thank you. Yeah. So I'm talking about the overfitting, you know, overfitting part right now. So, you know, if you can you know, arbitrarily closely represent any function in the class of functions that you're looking at, then you can overfit, and you can, you know, you will successfully learn whatever the thing is with any reasonable algorithm, but then you're not really going to generalize very well because, you know, you're basically asking the machine to do a slightly more convoluted version of just saying, okay, tell me whatever the values are for these particular inputs, I'll memorize those, and then I'll just tell you random nonsense for everything else. And so, like, if for many applications, this general type of thing is good enough, and people actually don't even usually bother to use any of the classical statistical learning theory to quantify how good it is that they did, or that they probably did. It's just kind of stuff that, you know, people just kind of do it until they feel like the results are good. They don't really worry about, like, how efficient they're being, or whether, you know, it's really, you know, like, if it's overfit, like, they just don't care, just over-parameterize everything. And, like, you know, that's what people do. But that's actually, you know, if you desired a more sort of intelligent result from your thing, if you wanted something that you would more characterize as intelligence, then you would probably not want to do that because, you know, you just going to overfit all the time, and it's basic. You might as well basically just be guessing random things for the outputs that it wasn't trained on, and so it's not really very helpful. So the idea is that instead of trying to fix the the traditional paradigm of using this class of smooth functions and gradient descent, that we should just use a different paradigm that is engineered to not overfit in this manner. And so that's what this code is doing, and that's what the paper is about. So if we switch instead of from using smooth functions to using a certain class of functions called polymorphisms, then we can guarantee that we won't overfit in certain ways. We can guarantee that there's a certain kind of structure that will be preserved by the neural net in question. And so, that's kind of the rough overview of it. Or I guess that's also what I mean by better. I'm pretty skeptical of that, to be honest, because there's a bunch of mathematical results about not just neural nets, but about just any algorithm that you have, whether it's something like a perceptron or just any kind of algorithm that you have for doing a learning task, that there's no mathematical reason why just continuing to train over and over on the same data should ever give you a better result. There must be some other detail that I don't know, if I'm being charitable, but of course, it's also possible that these people were mistaken or something. There's not really any good mathematical reason that I know of why any such thing should ever happen. It's pretty easy to give examples where that definitely is not going to happen, and those are pretty widespread examples. Because these things aren't extraordinary claims require extraordinary evidence, and so I think that I can't really say much more without seeing the paper, but I don't even. I guess maybe there's some kind of bizarre choice of pattern that you could do for some such system that it would be forced to get stuck on if you kept training it more. But I think that calling that learning the underlying pattern is probably misleading in that case, because it's just you've just kind of chosen the one weird fixed point. That's basically what it is, right? It's you have a function that's taking the neural net that you already trained, and you're training it more, and there's some fixed point of this process that you found. You found something that enters this particular fixed or attracting point in the space of possible nets, and then you're watching it converge to it and say, it learned the pattern. But I think saying that it learned that is kind of not it's a little bit misleading. Okay, thanks. Yeah, I will. Well, here, I'll just take a look right now. Why not? Here, I'll take a look right now. Let's see. Oh, okay. I'm gonna have to copy and paste the link because it takes me to some really evil internal web browser in OBS when I just do it that way. So let's see. Oh no, that's not the link that I wanted. Okay. Yeah. So let's just take a look. For what it's worth, I actually try not to read too many of these papers because it's usually pretty diminishing returns. There's a lot of stuff that just doesn't really address even like the basic theoretical, knowledge that we have about the discipline that we've had since the 70s or 80s, and there's a lot of economic incentive to just kind of spout nonsense. So I really wish that seeing OpenAI and Google in the authorship of the paper made me feel better about it and not worse. But there's some pretty strong incentives here to to say nonsense. They also use the word grokking, which is also kind of like like old business people trying to be like hip with the youth and use like some old hippie slang in order to like sound like they're like cool and like so California and everything, which is also concerning. Let's see. Alright, the abstract was not very helpful. I think, this is quite short too. Alright, I see, there's this appendix. Yeah, I think that there's no theoretical reason why this should occur. Like, this is just, they're just yeah, okay, alright. Yeah, so obviously I haven't read the whole paper since I've only had a short period of time, but I think that this is not this is not something that's very convincing. Yeah, I wouldn't trust this, honestly. Like, obviously I could give it a more thorough read, but like this, I don't see anything in what I've looked at that indicates that this should have any real useful basis. I think that what this is probably basically an ad from OpenAI and maybe Google to a lesser extent, where they're saying, hey, we know that there's no like mathematical reason why just dumping more computing resources into the same thing that we've been doing for years at this point should actually improve anything significantly, but we're going to just keep doing it anyway, and we're going to post this paper where we say we tried some experiments, and then we'll just kind of, say, okay, well, maybe every once in a while it seems like something got better, but like I don't think there's any reasonable basis to think that this is something that's a general thing that happens. Like, I mean, I can't say how bad it is, but like that's my impression at the moment, because these people have every incentive to say this, because like otherwise people are going to go, oh no, we reached the limits of what this can do by just dumping more computing resources into it, and now I'm not going to keep paying more money for them to make an even bigger version of the thing that is still not going to be any different than what it is now in 5 years. And people get tired of it, so you have to try to sell them that it's going to change. It's going to change and get better as long as possible, but it's just diminishing returns. Because of course the reality is that a lot of this is substantially the same stuff that has been around since the 70s or 80s. The only difference is that we have better hardware now, and so we can dump more resources into it. But the exact problems that exist now that I've been discussing, they were problems that people discussed back in the 70s or 80s. Even though the computers weren't as good, they understood that this was the case. Like, yeah, I mean, of course, you can use the the continuous ones on things that are discrete too, by just discretizing the values that are coming out of the network if you want to, and so people do that. People do that as well. But yeah, I mean, in fact, one of the things that was earlier on in this project that I didn't mention is I mean, the fact that OpenAI is primarily focused on marketing nonsense to people is not really a hot take. I mean, that's like the standard opinion of anyone that's not taking money from them, right? I mean, that's what it is. Um, but you know, yeah, actually, earlier on in this project, I mean, one of the examples is one of the examples that led to doing this stuff with polymorphisms was us looking at just what if I just use any discrete functions, and you can easily experimentally observe that you can't learn addition mod you can't learn addition mod 97 or division mod 97 or whatever, because you just overfit basically instantaneously. There's just it's not gonna happen. I've seen this experimentally a bunch of times, and I'll probably add some data sets about this to the paper when it's published too, because it's just it happens basically immediately. I mean, there's no reason to believe that should be learnable. Just using arbitrary functions, and arbitrary smooth functions is basically arbitrary on a finite for the discrete. When you discretize things, it's basically just using arbitrary functions. So yeah, that's not reasonable. But yeah, no, yeah, I mean, within okay, you know what, I really appreciate the suggestion actually about just showing me random papers and getting my hot takes. I'll do math. I'll do the areas of computer science that I'm somewhat familiar with enough to be able to talk about. I'm not going to do something that's totally outside of my wheelhouse. So if you give me, the latest stuff about dynamical systems or something, I'm going to say, okay, I know the basics, but I'm not one of these people, so I'm not going to judge their paper. But yeah, anything that's reasonably in my vicinity, I will be happy to try doing that sometime. I think that could be a fun stream idea. Just get exposed to some random things. And believe it or not, I will actually have nice things to say. It's just that there's a lot of questionable material in the area of artificial intelligence, and so as a mathematician, it's usually a little bit rough to look at some of these things. A lot one last bit of trash talking, and then I'll actually get back to doing something useful. So a huge fraction of these papers are basically literally just we have a big computer and we have this model and we ran the model on this data and it got us this result, and there's no actual mathematical analysis in the sense of that they're not discussing at all what kind of relationship there is between how many samples they took and how accurate they were. They're not looking at the amount of resources involved or anything. It's literally just we ran the thing for a while and now it seems like it's cool and that seems good and it's good. It ran better than the other thing that also we ran on this computer, and but it's it's so down, and it is necessary to do real experiments and have things yeah, exactly. So there's a big difference between something, we observed something happen one time, and there is an actual pattern here, and that difference is largely the existence of an actual mathematical understanding of what's going on. Even if you're not going to do it to the abstraction that a mathematician would, a proper theoretical computer scientist should be able to discuss, some of the properties related to the actual algorithms involved, should be able to actually quantify things in a way that's independent of the substrate that's being used. It's not I mean, in my opinion at least, computer science is not oh, I ran this thing on a computer and I saw that something happened. That's that's not computer science. It's not even really engineering, right? That's just, That's like saying that looking outside and saying like there's a bird is biology. You know, like it needs to be more than that. Um, yeah. So anyway, that's probably enough of me talking trash for now. Uh, so the reason why, okay, what I like about the README is that I can use the README to annotate where it is that I actually need to be working on things, because it's become quite a large thing, and so I have these things labeled organized that I need to do work on. So it seemed like the arithmetic operations were fine, and that was from our toy examples with arithmetic operations. I do actually need to do work on the binary image polymorphisms now, because that was the one. Oh, it does say organize here. Okay. Oh yeah, it does. Okay. Because that was the one where yes, that was the one where the additional thing had been added that I have to work with, and then okay, the Dominion one came next, and maybe I should reorder these so they're actually in the order of the alphabetical listing here. So then the Dominion one came next, and I need to rework that still. Okay. So yeah, let me actually put these in alphabetical order. This is the kind of organization that I'm talking about too. Like I need to, okay, I'm just going to do this. Need to be very consistent. Okay, so then this Dominion thing. Okay, oh. Alright, so that needs to be reworked, and then this hyperoctahedral one needs to be reworked, and that one's already labeled as well. Okay. It probably doesn't like the word hyperoctahedral, but that is the correct spelling. Yes, save it to the dictionary. I have another complaint, which is that there really need to be math dictionaries in there really need to be math dictionaries in these things, because it's so common. Even I've complained about it in Overleaf. Overleaf doesn't know the word, hyperoctahedral or whatever. It's like, with especially with them saying, oh, we're going to integrate this language model for writing and stuff. Like, okay, great. Can you use some of those tools to produce a dictionary of mathematical terms for the spell checker that it'll take 5 seconds? Like, they're scraping everyone's work to sell to OpenAI anyway. Just take 5 minutes and just make the spelling dictionary from people's most commonly used mathematical terms that get underlined currently. Like, no one can pull themselves away from assembling the data set to sell to Microsoft or whoever for long enough to do this. Like, it just seems unreasonable. And that's part of why I'm gonna transition away from using Overleaf, and I'm gonna start using CodeCalc instead. Because it's pointless. Like, why pay so much money if they can't even do the spelling dictionary? It's ridiculous. All right. Anyway, I'm gonna try to focus on happy things now. Okay, so the hyperoctahedral thing needs to be worked on too. And then let's see. This is stuff for pulling in the. I have a human readable version of the MNIST data set, which is big, but it's it's bigger than the usual traditional one, but it has the advantage of not having to unpack it and have separate code just dedicated to unpacking it every single time. So for the moment, for debugging purposes and just to make our lives easier, I have these things for taking these JSON files that are okay, most of the MNIST data set. It doesn't all fit into a single Git repo, and I didn't want to mess with the large repos that GitHub does now because yeah, I mean GitHub. Like the large GitHub only allows you a certain size for a repo. I didn't want to mess with the large ones because it's like it's another configuration thing, you know. But hopefully at some point, you know, maybe once the initial stage of this is done, can reinitialize on a different platform that's not Microsoft, and you know, have like a separate thing that's the whole MNIST data set in like human readable format. Maybe have like a binary format that I like better, or that just seems like more, you know, nicer to read. I don't know. We'll see. But at least for now, this is the stuff that's needed for reading from those JSON files. Yeah. Let's see. Is it upset? What is it upset about with my formatting here? Reformat, and it does nothing. Okay, what are you upset about? Continuation line over-indented for visual indent. Okay, but the reformat didn't do anything. Let's see. Okay. Alright, now it's happy. Alright, fine. Okay, other than that, and you know, sometimes I try to be more like parsimonious about touching everything in the repo in a single thing, but I'm just gonna go for it and just touch a million things. It's not like there are 20 of us working on this at once, so it'll be okay. Alright, I think that this is fine. It seems like everything at least was able to be defined correctly. This is the file that, okay, so that was MNIST. That was the MNIST training binary. Okay. Alright, and now we have the neural net one. This is defining like the basic structure of a neural net. Okay. So one thing that's a little bit of a difficult thing that I didn't really realize from the marketing perspective is that initially the idea about this was for discrete things, for neural nets that took on discrete values, but the actual setup is something that encompasses both the continuous and discrete paradigms. And so, you know, I'll frequently, I feel like now I've started to get people being like, oh, like, you know, well, like, how, you know, like, or like, can you do this in the continuous setting, or like, well, you know, I don't see how it makes sense if this is only for like the discrete ones, and now I'm like, why did I name it this? Because now people are going to keep saying like, oh, but, you know, it's like, they have to be discrete, right? And it's like, no, I don't know, that was the initial application, and then the name was that for the paper, but maybe I should just change it to just polymorphic learning instead of discrete neural nets and polymorphic learning or something. I don't know. I'll figure it out. But, oh, and then the other thing too that can be, okay, so I'm still complaining, but the other thing that can be annoying is that I've like given entire talks and like, you know, like describe this in some amount of detail to people, and then had them be like, oh, but did you try using like this smooth activation function instead? And then I just go like, oh my god, why did I spend so long talking about this when this person has no idea what I'm talking about whatsoever? And it's like, now, to be charitable, maybe they just didn't care what I was talking about and were just trying to pretend to be interested, ignored me completely, and then asked a question to show that they really don't care, and like the question doesn't make any sense. But I do think it's possible that a number of people have actually listened to me talk about this, not understood it at all, and then asked me this. And like, as I said, like, you could, you know, like the general abstraction does cover the continuous case for this, but like, I meant like, I'd be discussing the discrete situation, and they'll be like, oh, like, you know, why don't you use this? Yeah, actually, so the whole thing of this is that I want to use a certain class of activation functions that are really critical to getting, results that are not overfit. So, they're actually, they're actually fundamental to this whole project. I'm also using the word activation function, yeah, in a sense that's not exactly the traditional one, because to me the activation function includes the dot product that is like taken usually. Like if I was going to describe that in my setup, the activation function wouldn't be just like the sigmoid; it would be the sigmoid composed with taking the dot product. So I'm sticking the weights into the activation functions as well. And so then, in that sense, you've got to care about the activation functions, because my activation functions have all the data that the weights have too. Okay, so let's see. So let's see if this will just even. Okay, so that runs. Probably doesn't need to be messed with. All right, let's see about the operations one. That doesn't need to be messed with. Okay, so then neural net and operations are fine. And then, let's see, polymorphisms is the next one. I like seeing the imports. I don't need them to be hidden. You shouldn't be using too many imports anyway. If you're embarrassed about all your imports, then like something's probably wrong. There's always some big drama. There's always some big drama where somebody made some like ridiculous dependency that like 80,000 projects on GitHub are dependent on this one project, and then somebody else gets control of it and like puts something malicious in there, and it is like this huge security flaw, but everyone just keeps copying like the import whatever package from Stack Exchange, and now it's automated with people using like AI tools to put in these like pointless, create these packages that have like these pointless dependencies, and the dependencies end up getting, turned into these malicious things, and like it's not necessary. Like just, keep it simple, right? Like it's you don't need to import a million things. All right, what is this angry about? Unexpected types. No, it's always angry about this. Why is it trying to interpret these types this way? I don't actually really. Which part of the? It wants me to invert the if condition. Why? What do you want? Why do you like that? You want me to pass? That's better code than just saying if it is equal to that, then do whatever. Okay, I don't know if there's something deeper down that is making that actually better from an efficiency standpoint for Python, but that's ridiculous. I'm not going to say if it's not equal to, then pass, and else do something else. I think that's preposterous. Is there even like a Python? Is there something in the Python docs about this? No, it's just some evil that PyCharm is trying to put on me. And here it says unexpected types. Like, that can be a string. Alright, this is preposterous. I'm not going to listen to this thing about this. I've seen it complain about this before, and it still makes no sense. It's pointless. Alright, anyway, did this run? Am I happy? Alright, this is fine. So this file is fine. Random neural net. Nah. I'm just being obsessive now, but I'll leave it for the moment. Okay, that seems fine. Relations. This is the file in which I had a fun adventure of trying to figure out if I could make a truly immutable object, like a truly immutable custom class in Python whose objects were actually immutable. And the answer seems to be no. You You can do a lot of things that make it close to being immutable in the sense that the built-in types are, but you can't make your own immutable types in Python. You can just get very close in a number of different ways. But unfortunately, that's the best that you can do. Okay, so now I had a previous note saying that this test is something. Oh yeah, this is like some old. Okay, this is like some old code that is very old and just needs to be like processed or disposed of at some point, I think. Alright, so that does need to say organize. Let's see. Now we can move on to the tests where hopefully things will actually happen. So let's see. The first one in the list is this. Let's see. Yeah. I'm so tempted to make a decision about whether this space is here, but I just have to ignore it. Let's see. What are, let me just see what that is. Things are happening. Let's see. So, okay. This is going to do something. Why is this test written like this? Oh, okay. Matplotlib is building. Oh, is building the font cache. Okay. Let's see. Okay. Setting an array element with a sequence. The requested array is an homogeneous shape after 1 dimensions. Text 2 plus inhomogeneous part. Okay. So something has been changed on this, so that it is. Oh, right. Of course, because these Dominion polymorphisms are the ones I was trying to integrate the new code for, and like this is the thing that's testing that. So okay, fine. It should be all messed up probably, because I'll have to readjust it to fit the new code. All right, great. Okay, that already says it needs to be organized. Fine. Okay, I know, even without testing that needs to be dealt with. Let's see, test binary relation polymorphisms. This is a bit newer, and so hopefully it should actually work. Ah, it works, great. All right, so this is testing some of those. This is testing some of the polymorphisms that aren't the Dominion ones, and let's see what our results look like. It did finish. All right, so let's see. Original image. It's a relation. This is the original image. It's a 0 from MNIST. When we rotate it, it turns into that. Okay, that actually makes sense. So that seems like it's not messed up. Rotated half a turn, 3/4. Okay, this is looking good. Reflected. Rotated and reflected. I think that this looks fine. Image to use for swap. Swapped image. Okay, that seems okay. Blanking. Blanked image. Okay. First image for dot product. Second image for dot product. Image. Second image. Image obtained. Okay. I think that this is okay. Yeah. Alright. I don't think I need to fiddle with this right now. I think this is all doing what it's supposed to, so that's fine. So that one, I think, is happy, and so that's testing the basic functionality for the polymorphisms and applied to binary relations. So the actual data for these is like binary or maybe higher arity relations. So the actual data being plugged into the nodes of the neural net isn't just like some float, some value. It's a relation. So those are like basic numbers, at least in these examples. Yeah. So. Oh, sorry, I missed the literally me before too. I'm not sure what that was referring to now. I just realized that. What was literally you? So we did the binary relation ones. Test Dominion is next. Okay, that definitely is going to need to be reworked as well. Not knowing what. Okay. Yeah. Well, the best way to find out what people are talking about if you're really interested is to, continue to engage with it and, and think about it and stuff, and, you'll get there eventually. When I was younger, I used to just go, I just go to like Wikipedia, which was pretty new at that point, and I used to just go to like a random page about something in math, and maybe it was something I knew about or knew a little bit about, and then I'd click onto something I didn't know as much about, and I'd go for a little while until I got to stuff that I understood like only a little bit, or just like very, very little, or basically not at all. But I'd still like kind of at least skim through and like check it out and be like, oh, this is kind of what it looks like, and I wasn't like memorizing nonsense that I didn't understand, because that's a waste of time, of course. But like I was like getting a feel for it, and over time, as I'd explore further and further out, just like learning a new language, things start making sense. It didn't make sense before, and so I now now I look at Math Wikipedia and I'm like all these articles are just like the most like half baked, like there's not even any information on them. You can't even you can't even find any of the basic stuff that you'd want to look up. But like when I was younger, I was like, oh wow, like this is so involved. There's so much detail here, and like it's I mean it's really the best way to do it. I feel like I've heard of Dominion being a game, but I don't know what it is. Yeah, I think that so I don't all right, so I'll say something about Wikipedia. Maybe I'll edit Wikipedia anonymously or something on this stream, but I do edit Wikipedia sometimes, rarely, and the account is not obviously connected to my professional identity, but I will say that I stick to topics that I'm an expert in, and the reason why I'm hesitant about getting more into editing Wikipedia is because I have found in the past that people, hey buddy, oh, are you excited about Wikipedia? Dobby donates to the Wikimedia Foundation all the time. Like he's really into it. Okay, buddy. Yeah. Are you a big fan of what is it, Jimmy Wales? Do you think he's really cool or something? Okay. All right. I love you, buddy. You're a good dog. Okay. Yeah. Go play. Go get it. Yeah. All right. So yeah, people kind of have turf on Wikipedia, even in the math articles, which is like ridiculous. And even sometimes if you are like, you have like references for what you're saying, like you have like a bunch of like good sources, like everything is like, okay, like this is clearly what's going on. People will just say, no, I don't like your, notation or whatever, even if it's like literally what everyone in the area has been using for like 20 years. There's just people who are like retired or something, and they're like, like just sitting there like camping at the Wikipedia page, and if anyone tries to touch it, they're like, no, you're wrong, and you're like, I have like all of these references, and like this is clearly like the state of this area right now. And they're like, no, you can't touch it, it's my page, I own it. And of course, like, I have better things to do with my life than fight with someone over a page on Wikipedia. So that's why I'm hesitant. But I have written some Wikipedia pages before. Yeah, so that's the best time to really get into like starting to check out what professional mathematicians are doing is, later on in your undergrad career, you definitely have, you've had abstract algebra, real analysis, topology, you're ready to start, checking out some of what people are doing, and that's a great way to move on to the next stage, like it's definitely a good time to do it. Oh, hello again, Garbage, welcome back. Yeah. Yeah. Abstract nonsense is definitely a lot of fun for sure. Um, Oh, and as far as NLab, unfortunately, so even until really recently, because there's like the N category cafe that like people write blog posts for and stuff, I assumed that NLab you had to like be like allowed to edit NLab because I've just never bothered trying to edit NLab because if you've looked at any of those pages, you know that it's more hopeless than Wikipedia. Um, because a lot of it's just like, you know, something that has like no references or the reference is like an 800-page book in which the thing is mentioned as like an off like a side comment and never developed at all, and like you'll like look at you'll look at one of these pages and you'll be like, what is all this? And it's literally like just some random anonymous person like made up some stuff and they wrote it down and they said you could probably define this or maybe this will make sense, and a lot of it is either just literally wrong or it is like someone saying, oh, maybe you could define this and then not doing anything with it, and like it's just it. Okay, so I love category theory, but and the NLab wiki is like a lot of the worst problems of category theory socially condensed into a single document. Like that's pretty much what it is. And so I use a great deal of caution when trying to read anything from it, and I've never added anything to it. Because it's like it's not just like, oh, this happens on new pages or something. It's like half the pages. Like it's pretty wild. Yeah, there's people. Yeah, there are good people who contribute to it, but the reality is that there's not enough energy going into it. Like the only reason that Wikipedia is halfway decent is because there's enough like time and energy and money going into it that like it can be it can be to some extent like policed for quality or whatever, but like the NLab is just it's just kind of the Wild West. Like yeah, there's some good people who add things to some of the pages sometimes. Like it's not like there aren't, but like go to random pages on the NLab and you'll experience this. Like it's pretty rough. And if you actually are interested in studying something, you're going to find that you start finding false claims on the NLab pretty quickly. And that's what happens when anyone can edit it anonymously and there's no, there's not like very strict efforts to enforce referencing things or anything. Like it's just, whatever. Yeah. Yeah. Thanks for. Oh, you're back from looking at the document, or looking at the preprint. Yeah. So there are various discrete analogs of differentiability. Oh yeah. Thanks for checking out so much of it. There are various discrete analogs of differentiability, well, what do I want to say? I guess, I have experimented with some of these. I haven't seen anything that I'm crazy about yet, but I have experimented with some of them. I am not sure what you're referring to from arithmetic geometry. Arithmetic geometry? Well, whatever the emphasis is. Yeah, I mean, it's conceivable that such a thing is possible. Yeah, arithmetic geometry, like arithmetic progression. It's etic, yeah. I haven't gone too far in that direction. I do have a sequel project going on that I talked a little bit about last winter at Cambridge in the New York Category Theory Seminar, and I will have some more comments related to this whenever that comes out, probably. But the general picture of this is that I'm able to do whatever it is that I'm doing here without using a notion of differentiability. SQL, the English word SQL, not like not database. I've just been using JSON for this at the moment. Um, but yeah, um, yeah. But yeah, the general picture is that I'm not needing anything like differentiability to do what I'm doing here. Of course, if you have it, it can be nice, but that's not the aspect of sort of not the aspect of neural nets that I'm generalizing. So we have algorithms that are like uh, that work independently of whether you have differentiability or not. All right, this thing. Okay, somebody's put to do here. So this was the test. Okay, this was actually the test of getting the arithmetic training for learning arithmetic functions, which just should overfit, pretty intensely if you're using arbitrary functions. Although here, it seems like we were actually using arithmetic operations, so it's conceivable that it's possible. Because we're asking what compositive functions will give us the thing that we want. Oh yeah, well, part of part of grad school is is exploring. I mean, I assume maybe grad school, later undergrad if you have an advisor. You're going to explore different things and different people's advisors are more or less strict about this, but as long as you're learning something, it's probably cool. Let's see. So I think this is also for using those dominions. So I think that let's see. How is this being encoded? All right. I'm not sure if I think that wasn't done. So I'm gonna just mark that I need to do this. So that's see, mod arith. You know that I didn't name it because I would have written the entire word arithmetic, probably, or arithmetic if you prefer it as an adjective. Let's see. So that was that. I know that this is something that was from the old implementation. Let's see. This thing I think was working the way that it's supposed to. Let's see if we can actually get it to run and be happy. Oh my god. Okay. Well, it definitely ran. What did this do? It made a bunch of training pairs from MNIST, probably just for the task of image classification. Display the corresponding label. Test pairs. Display the corresponding label. Can you see the digit in the array? Training pairs. The digit 1 is labeled with an all white. Okay, yeah, all right. So this is for identifying zeros and ones. That's a 1. That's a 4. Okay, yep. This is doing what it's supposed to. So this is just for testing that the training. Yeah, of course. I'm glad that you have a nice advisor. It's good to have a nice advisor. Yeah. Okay, so zeros labeled with all ones labeled with zeros. Okay, so this is just showing that I've successfully done the conversion of the MNIST training data into the format that I want. So that's good. That works. The README says as much. So I think that we're happy with that. Let's see. And then test neural net is next. What is this doing? Wait, so is it arithmetic operations or arithmetic operations? Because I would say here arithmetic, because it's like operations related to like elementary arithmetic. If it was an arithmetic operation, I would expect it to have, some other properties that are not just elementary arithmetic. What do you think? On entering a master's degree in math? Oh, you're starting a master's degree. Well, So my general advice for grad school, um, yeah. So just really quick. Well, okay. I guess my question is, all right. If you want to know what's, if you want advice about what you're doing with your master's degree, I guess my question is, like, why are you doing a master's degree in math? Like, do you want to go on to do a PhD, or are you trying to go into industry? And if so, like, where? I think just, I can try to give you general advice, but if you just tell me like a little bit about like what the purpose of you getting a master's degree is, then that might really help to, give you better advice. Oh, and I am also working on having I have a list of things I want to do, like one of those like advice for undergrads, advice for grad students on my website. I've been collecting things for one of these pages of advice that I would give, and so I will share that at some point as well. But yeah, if you just let me know, like just kind of, whether you're thinking more academia, industry, and maybe some detail that would be helpful in giving advice about grad school. And I can say a couple things about it. Oh, yeah, yeah. Maybe the French language is affecting the arithmetic, la géométrie, arithmétique, something like that. Je parle français seulement un peu. Je sais comment dire ces choses que je dis maintenant, mais je ne sais pas comment dire, anything else. I can't even, all I can do is explain that I can't speak French, right? Okay, maybe I can say a few other things, like salut, je m'appelle Charlotte, but yeah, like I can read French like okay, but yeah, my accent's pretty bad because I never get to practice. I really need to learn Spanish better because I live in Colorado, and so there are many people who speak Spanish. Oh, okay. I don't do algebraic number theory. Oh, it's just geometry. I see. Oh, okay. So you're probably doing a PhD. You like research, number theory, algebraic, and analytic. Yeah. I mean, if you like abstract nonsense things, then you might be interested in. Not sure who the best advisor is for this type of thing, or like what area specifically, but like, there's actually a lot of interesting connections between techniques from group cohomology and the Riemann zeta function, or just zeta functions in general. So this number theory stuff isn't really my forte, but if you want abstract nonsense with your number theory, then like, I mean, I'm sure there's many places, but like, I mentioned, I know this factoid that's selling group cohomology, but part of what got Sarah the Fields Medal was using techniques from group cohomology to compute certain values of the Riemann zeta function, as I understand it. And so you definitely can have both. I'm not sure who the best people are for it, but yeah. Oh, yeah. Yeah, I don't want to get. I personally don't want to get involved in the messing around with the Riemann hypothesis. But I wish you the best of luck if you choose to do that. Okay. So as far as PhD advice, so if you're in a master's program, I take it that you, due to either your country or just your school or whatever, you couldn't get right into a PhD program, or this was just the best school you could get into, but they didn't accept you right into PhD. If you can, as early as possible, being a PhD student is usually better, at least in the U.S., which is what I know best, because I'm American, I went to school in America. You don't get paid a lot as a PhD student, to put it mildly, but you you just have maybe some grading or light teaching type duties, and you can focus on learning and doing your research. And you don't have to pay usually in the U.S. You get paid instead, and the tuition is free, or in exchange for your work. And so that's definitely a better situation. I definitely recommend that you choose an advisor based on how well you get along with them in addition to your area of interest, because if you don't, you're going to have a bad time. Don't just choose a more famous advisor or an advisor who publishes more because you think that that's going to be better for your career. If that person doesn't get along with you, even if they're a perfectly nice person, if they just don't get along with you well, that could really ruin your career or maybe just your whole life. So you really have to make sure it's someone that you're going to have fun spending many years with, and probably will have some effect on your career for the rest of all time. So you definitely should try to make a choice based on that compatibility as well. Now, it doesn't have to be perfect. They don't have to like your favorite flavor of ice cream or whatever, but you should try to make a choice that takes in the human factor into account as well, or you're going to have a bad time. Other than that, I highly recommend, if you're not already proficient with tech, get proficient with tech. Start writing up stuff as though you're writing papers that you're going to publish as soon as possible. Unfortunately, the way of things now is that you really want to try to publish while you're in grad school if possible. Especially if you don't have an undergrad research paper already from doing one of those, you really want to publish as soon as possible. I know it's unfortunate because the best work doesn't always get done in a short period of time, but that's the situation with the job market. So if you want to be an academic, you've got to really try to get yourself out there. Oh, also similarly, lots of conferences. Yeah, it used to be the case that people would finish their PhDs without any publication and just the thesis would get them a job, but that's, especially in America, that's not the case anymore. You want to have papers before at least you should have preprints that are being considered, but you want to have papers before you finish. Unfortunately, even people finishing undergrad have papers now, and so it makes it pretty competitive because there's the sort of the senseless metrics part of academia that you have to try to do your part to be part of the gamified system and support the publishing companies and everything. And so it's best to have papers. And also, it's just good practice anyway, because you want to work up to having a good pace. But I also definitely recommend conferences and getting to know people as much as possible. Cold email people if you have to, but make sure you have good questions to ask them. Don't just cold email them and say, I want to be famous like you or something, because that's not going to work. It's really unfortunate if you're in an area that's far from, where people generally have conferences. If you don't have a lot of money, it's going to be harder. Part of the test of grad school is how rich you are or how good you are at getting money from other people, in addition to whatever you're being paid. That's just the reality of it. It's not right, probably, but especially in America, that's the nature of things. You've got to have a lot of money if you want to get into the best position early on. So do keep that in mind. What's going on here? Oh yeah. Oh, that's okay. You couldn't find the precise wording. That's all right. Yeah. So let's see. Oh yeah. Yeah, so I am going to get back to neural net stuff, though, and I'm glad that people are having a nice time with the Riemann hypothesis in the chat. That's good. Yeah, do let us know if there's any big progress on that. It'd be pretty interesting. Yeah. Actually, there's also equivalent statements. I'm not a number theory person, but they're equivalent statements of the Riemann hypothesis that just have to do with the distribution of the prime numbers. So there are like definitely more elementary statements of it as well, you know, that you can explain even without having to, you know, to talk about analytic continuation or anything. Okay, so let's see. Where was I? Oh, I was at this test. Oh, this is the. Oh no, this is the test for a discrete function. All right, let's see what this is doing. Let's see. It'll take a few seconds to learn to replace a randomly chosen function with addition. Okay, great. So what is this doing? This is a neural net that has, let's see, this has, first layer it has 2 neurons. Oh, thanks. Yeah, I'm glad that the advice was helpful. I have a list of things that I mean to put as a, there's a word for it, but I'm now spacing on it, like a page of advice for grad students and undergrads, and oh, it's a one-pager, that's what people call it sometimes. I have a list of things in a file in my computer that I'm going to add a page to my website that's a one-pager. Oh, okay, here, now that I'm thinking about the one-pager thing, I'll give you some other, advice that I just remembered from it too that's quick. Mailing lists. Find mailing lists and join them. Mailing lists are like services that a server distributes email messages from anyone on the list to everyone else, so that you can have like group chats on email basically. You think like, oh, why should I use that when there's like Discord or whatever? That's because like there's a lot of really great people who have interesting things to share who are much older than you, who have been using these mailing lists since, you know, Usenet days back in the late 80s, early 90s, whatever, right? And if you get on these lists, you're going to see a lot of great advertisements for jobs. There's going to just be a lot of interesting discussion. You can ask them for, you know, resources, just try to get the feel for the culture of the list and be polite. But there's great ones for category theory, algebraic topology, universal algebra, and it's a really great thing. So I definitely join mailing lists if you can. What was the other thing? I feel like there was something else like that. Like join mailing lists. Now I'm trying to remember. I said stuff about getting proficient with tech. Yeah, depending on your area, I would also recommend learning to code, especially if you're not really sure if you're going to actually go into academia or not. Like clearly being able to code is helpful for me because I'm doing stuff that's also in theoretical computer science. But if you're not sure if you're going to go into academia or not, like you think there's a chance you might not, or you might not get a job or whatever, then having some basic ability to code is helpful because you can use it for both organizing and automating some tasks that you have to do related to teaching, administrative stuff, whatever, but also because you can use it to do mathematical experiments, which can really be helpful to you in doing your research. Even if it's not anything that's worth putting into the actual paper itself, being able to use the computer to experiment with things or to like just do certain tedious things quickly is very helpful. And at least for the foreseeable future, I don't think that these, you know, that things, you know, products like the ones from OpenAI or whoever are actually going to be able to do this kind of coding for you because they don't understand what you're asking. Or maybe a better way to say it is that if they understand what you're asking, you're not really at the point where you're doing original research yet, probably. Because understanding what you're asking usually means that someone posted the exact code that you're asking for on Stack Exchange at some point, and that's what it's copying from. And so, you know, you're going to want to actually know how to code in Python at least a little bit. And then, worst case scenario, you do end up going into industry. If that's not, you know, wasn't your original goal, but you just need to get a job and that's the job, well, hey, you already know how to code. Don't be the person who tries to learn how to write Python in the last 6 months of their PhD when they feel like they didn't get any postdocs worth taking. That's a sad state of affairs. for what it's worth, I'm not referring to any specific person with that. It's a thing that happens, and try not to let that happen to you. Plus, there's also lots of great computer algebra systems like Sage Math, to plug Sage, that are very useful. For doing such experiments mathematically. Oh yeah, lots of actuaries. Yeah, the NSA is the largest employer of mathematicians in the U.S. The largest single employer of mathematicians is the National Security Agency. Magma and Maple and Mathematica are fine too. Sage, Sage is just Python being used to duct tape together all of the different older computer algebra systems, and then there's some nice category theory stuff that's glommed onto there, and it's just buckets of fun. I've really enjoyed Sage over the years. There is I won't say that there's certainly an aspect of meritocracy to academia, but there also are factors such as luck and various socio-political things as well, and so unfortunately you have to have the right combination of a bunch of attributes to get any positions. And of course, even if you're like me and you've got a couple postdocs, that doesn't absolutely guarantee a good tenure track position. But yeah, at least I'm still in the running, and hopefully I'll make it, whatever exactly that means. It also there is an aspect of it where if Debbie, it's okay, buddy. It's okay. Debbie, come here. That's okay. Just ignore those people. It's okay, bud. Yeah, if you just kind of dump all of whatever little money and energy you have. Okay, just a second. All right, Debbie. Debbie, come here. It's okay, buddy. It's okay. It's okay. It's just that. Oh, it's actually the mail. He's actually barking at the mail. You're like a stereotypical dog, buddy. It's okay. It's just the mail. Anyway, if you just dump all of whatever little money and energy and time and everything you have, no matter what, into this, and you just neglect other aspects of your life, then you two can potentially either achieve success or really go down fighting. One of the two things. It also is good to be creative and be original. Abby? Oh, and that's also why it's good to make sure that you actually can prove all the things yourself, and you can actually do all of the things that you're, referring to as much as possible, because a lot of your competition is going to be trying to automate it away using language models. And so those people are going to be absolutely, they're going to be putting money into just actually making themselves weaker. And if you can work yourself into being able to do all that off the top of your head, you're going to be way, way stronger than them at the end of grad school. So, you can really watch it happen in real time. Take somebody's phone away and see what they can do. The results are surprising sometimes. Let's see. Okay, so I made this thing that it's going to have input and output values that are mod 100. First layer has 2 neurons, and they carry modular addition on one of them, and just some totally random operation on the other one. And then the third layer has a single neuron, which is multiplication. Okay, and we can feed forward to feed the result, to see the result. So if we plug in 0, 1, and 2, we get 2 apparently. And then we're going to try to get it to compute first thing plus second thing times first thing plus third thing. Mod 100. Okay. our empirical loss initially is pretty high. Like 1 would be like perfect failure. And then, let's see. I'll just say that you can either switch to modular addition, mod whatever the order is, modular multiplication, or just some randomly chosen operation that's binary. Well, we start training using this naive algorithm that we have, and after a few steps, 5, we see that we have a perfect result. And that's because we restricted our class of functions. There is this random operation that was possible, but that usually does so terrible that it's just basically ignored. And we pretty quickly learn to model x, like x naught plus x1 times x1 plus x2. Okay. So the reason that this works is because the class of operations is so small that you can't actually generalize perfectly, because it's just, there's a small enough space of functions. And if you look at the old school statistical learning theory, then you'll see that that's a really fundamental consideration. When your hypothesis class, when your possible models are restricted, then you can actually have success in doing learning tasks without overfitting, because you restricted the things under consideration enough that you can make a sensible choice. If your hypothesis class is really big, like all possible functions, then you just get nonsense and you never successfully generalize. Yeah. So, Debbie, who's a good boy? Okay. It's okay. The male people they're still here, but they're gonna be gone soon. Okay. All right, come on, bud. Do you want to say hi again? You want to say hi again? You did it. Yeah. So, there ain't no such thing as a free lunch, right? On Stoffel, you can't. You're not gonna get something for nothing, and unfortunately, just dumping more power into it isn't gonna help. You have to kind of have them, garbage. It's also like a garbage in, garbage out kind of thing. If your possible models include everything, including lots of garbage, you can probably expect to get lots of garbage out. Okay, so this works, and that was nice. So that was the test neural net thing, and that's fine, and it says it's fine. Test polymorph. Oh, okay, what's this? It's binary image polymorphisms. Okay, I think that this is old. Maybe, let's see. Oh, no, it's not old. It's just something that I haven't worked on integrating yet. And part of the reason I can tell this is because I have the structure of this set up so that this path isn't necessary. Yeah, okay. So, let's see. Okay. Alright, so I still need to integrate this. So this is test polymorphism relation, add description, okay, good. And then test relation. So these are the basic functions for the relation class. Let's see. Okay, it seems like all this is cool. Alright. So, let's see what's going on here. Made a binary relation. We can display some information. That makes sense. There it is. It's a frozen set. It has 3 things. The things are these things. We can take some different ones. This is the relation R. This is the relation S. Okay, all of this seems good. They have IDs. Okay. I think all of this is fine. Alright. Shows a picture. We can have it generate tech for us. Okay. This is fantastic. Alright. So that works the way it's supposed to. The README says as much. So that's nice. Environment. Yeah, this is actually where I describe for everyone where how to set the project structure so that it will import correctly. All right. So I've gone through all of the files that are listed in the README. Oh, but I do have some other tests here with different architectures that I haven't listed in the README yet. So let me check these out. Let's run this one. So these are all testing without those Dominion polymorphisms that I have to integrate in. So they're probably not going to work as well because those Dominion ones are really the interesting ones that are more helpful, but it should still do something. So this is training on MNIST to classify zeros and ones. It made a very small amount of progress, but that's not really shocking because this is a very restricted example, but it works in the sense that it runs and it does improve our empirical loss, and it works. It does give us a similar result on the test pairs as well. So that one's fine. This is actually just one where we have just a path as the architecture, so each node just has a single input. So this one's not too exciting either. Let's see. Oh, this has 100 layers though, so it's really deep, but it's not wide. It's just got a single neuron in each layer. I don't actually remember what happened with this one. This is also training for binary image classification. Let's see. Well, I guess it's just still running, huh? Did I ever get this to work with 100 layers in it? Seems like a lot of resources. All right, let's see. Maybe I just like randomly said it was 100. I wanted to do 100 layers, but let's try to do 10 and see if we actually can get something. Yeah, I'm not really sure what's going on with that comment in the chat, but okay. Let's see. Got 10 layers now. Or actually, yeah, I think I just want to reduce this whole thing by an order of magnitude because I also said I wanted 100 steps. Let's do 10 layers and 10 steps. Oh, sorry, I'm not familiar. I did not. It's okay. I understand now. It was a religious reference. I was just not familiar. Okay, so let's see what things are being printed. The original empirical loss, and then let's see, 3 things here. Okay, so the original empirical loss I have, and then it does, okay, the report loss is the second one. So that's after training. And then I have the test one. Okay, well, that's not too shocking. Let me just, I don't know why I made this so large. I don't think that I had this running that fast before. Like, okay, what if I just do something smaller but train it more? Maybe this was the last experiment I was messing around on and I just pushed it because I decided that I was done with it. I guess I could try maybe 30 instead. Let's see. I mean, I don't expect anything wild, but I'm trying to remember like what the general behavior of this was. This is just kind of a more trivial experiment, though. I mean, it makes progress. Okay, maybe let's go up to 50 and see what happens. Let's see. It's okay, buddy. It's okay. Oh, I see. Of course, the postal people must have just parked in front of our house, and they're just going to all the houses around, and then every time they pass by, they have to get something out of the car again. Then my dog's getting stressed out at them. All right. Well, it's a similar improvement. Okay, we didn't expect anything wild there. I'm just gonna leave these constants for now. I think I'm just gonna not actually mess with this. All right. So, well, at least it works. Random architecture. There was some issue here. So really we're just using a single binary one. Alright, well I think that probably needs to be worked on then, and what if I just train a single node? What happens then? Oh, yeah, I remember this experiment. So I like this experiment. No, I don't talk to myself if I'm not streaming. So my progress doing this now is significantly slower than if I was by myself, because when I'm by myself, I don't talk to myself and I don't explain anything. I just sit there and do the thing. Yeah, so, okay. So actually, single node did pretty well. It improved. I think what this is showing is that if you give it more zeros than ones, then it guesses that everything, or if you give it whichever one, if you give it lots of zeros and no ones, or like only a couple ones, it guesses that everything's a zero. And this is like the really boring case. So there's just literally a single neuron, like a single node, and so you might say, okay, well, what's so great about that? It's just if you give it more of one than the other, it guesses that everything is the one that it saw more of, But that's actually already interesting, because with like traditional, the traditional paradigm that people do, if you kept training it more, it would decide that exactly the ones that had been shown that were special, that were ones, say, if most of them are zeros, it would like memorize that those exact pictures of ones were ones, and then it would do whatever else on the other inputs. But like it's not really, that doesn't really seem intelligent if you think about it, because like it's kind of like the intelligent thing would be the lazy thing of saying, okay, well, you basically showed me all zeros. If I want to do a good job at guessing whether something you showed me is a 0 or a 1, and like 99% of the time you show me zeros, I'm not going to bother trying to learn what a 1 is. I'm just gonna tell you that everything's a 0, and I'll be right most of the time. And that's what you want. That's the smart but lazy choice to get a good score. All right. Anyway. Oh, well, yeah, different people talk to themselves, or have different ways of working things out. I'm not going to say I never talk to myself, but it's not, I don't talk to myself a lot, usually. Let's see. Yeah, I'm not really sure about the comparison to simulated annealing, but yeah, there certainly are other paradigms out there. It's not like neural nets are the be-all, end-all of machine learning, But yeah, I'm not really sure what the comparison is here. Part of the issue in setting up the comparison is that you have to, if you know, for the thing that I'm doing right here, you have to describe what the translation is between the discrete and continuous analogs of the problem to make it comparable. And of course, depending on how you're optimizing, you know, it's part of the reason why you need, you know, you need to have some of the theory behind it is because it's really apples to oranges if you have two totally different, two totally different setups. It really could come down to the type of hardware you're using, you know, the language that you're using, whatever. And so, you know, that's part of the advantage of theoretical computer science is that you can actually, you know, discuss things a little bit more abstractly and have like a notion of an equivalent kind of computation instead of just saying, oh, we ran it on this one, we ran it on this one. Like, it's kind of like how if you go and look up like, oh, you know, everyone says that Java is faster than Python. How do I know that Java is faster than Python? And then like you start looking into it and the details are like, well, you know, there's not really a single like objective measurement of this. I mean, certainly, you know, certainly, like, in some sense, Python could be just as fast as Java because there are Python interpreters that are written for the Java virtual machine. And so, you know, like, it really gets pretty interesting what you mean by as fast or equivalent or whatever because, like, it's, you know, these things are pretty different from each other. You know, what is the meaning of two equivalent programs for different, you know, a different programming language? You know, one of them's interpreted, one of them's compiled. You know, like, well, what if you're allowed to produce, you know, like, you know, Python bytecode first? Like, it's really, you know, despite there being like conventional wisdom, you know, you know, it's actually kind of a complicated thing to answer if it has an answer at all. Oh yeah, yeah. Sorry, it took so long, but yeah, I know. I'm on mountain time. It's kind of like island. It's like the opposite of island time. Like, you know, it's you know, it's similarly like laid back, but it's more like rock climbing and less surfing, I guess. Maybe is the thing. We have lots of Californians here now too, so it's got those California vibes. Oh yeah, I'm not really too familiar with anime, so I don't know what the conventional wisdom is about those things. Yeah, but yeah, my knowledge of Japanese pretty much extends to using the hiragana yo for the Uneda lemma. that's about it. Okay, I can say like a couple words, but oh, okay. Yeah, I just totally missed the pun. I am not familiar enough, and I just totally missed the pun. But yeah, okay. So let's see. Well, I messed around with the single node thing. So I still need to seems like. Oh, did I test this random architecture one? Did I do that? Oh, I think maybe I did. Oh, I said there was some issue, so I'm gonna actually just ignore that because I know there's some issue. Okay, so let's see. Those are all in this. Okay. Oh yeah. So up here I have those in this subdirectory. Add description. I'm probably just gonna leave it at that. So I've at least seen that everything runs that at least did run before, and now I know what I need to work on. So now, after 2 hours and giving various random advice and talking lots of trash, I have reminded myself of what's going on with this project. Oh yeah, Suzuki groups. That's right. Yeah, I mean, of course, there's plenty of Japanese names and math, and I guess that's the thing that I know. Okay, I guess to be fair, I also did take a couple semesters of Asian history when I was in college, and so I do remember some stories about Japanese history. I'm not the best with names, but I can give you a rough outline of Japanese history. Um, but and also discuss maybe some topics related to like things to do with feminism and like women's role in Japanese society. I have some knowledge of such things, but not. I wouldn't say I'm an expert by any means. Let's see. Oh, and you're going to. Oh, nice. You're going to you're going to Japan in 2 weeks. Yeah, congratulations. That should be cool. Actually, Research Institute in Korea is paying for me to visit next month, and so I'm going to be in Korea for a couple weeks next month, which is really cool because it's very expensive to fly to Asia, and I definitely can't afford it right now. So it was very nice that they're going to fly me out there. So yeah, I'm looking forward to. I'm going to be. I think we'll just miss each other, but I'll just right after you're in Japan, perhaps I'll be in Korea or something like that. So yeah. Yeah, it should be pretty cool. Yeah. Now, I think I know slightly more Korean than Japanese. Of course, it was a lot easier to learn how to read Hangul than it is to learn all of the writing systems involved in Japanese. I don't really think I'm going to do very good at having conversations in Korean, but I'll at least be able to function at a basic level. Oh, okay, yeah. So you'll be in Japan while I'm in Korea then. Yeah. So just wave across the sea there, and we'll say hi. I definitely won't be making a trip over to Japan though. This is already just going to Korea is already going to be more than enough for me. I'm getting a little burned out anyway from the travel, and so I need to just take it easy. It's both expensive and also very energy consuming. Like, I like traveling, and like maybe in an ideal world I would travel fairly often and I'd get more acclimated and stuff, but I think just this one big trip this year will be enough, because going to Europe twice last year was already a lot. Oh, they do everything in Korea. I mean, like it's they have quite a few people doing research there. It's pretty competitive as far as like the jobs, but they have a lot of pure research positions. I mean, there's way more people who want them than there are positions, but they have a lot of pure research positions. And it's pretty it's pretty developed. Korea is pretty developed mathematically. So pretty much whatever you're interested, I'm sure you can find it. Of course, there are areas that tend to be favored, I imagine. Like, I know, for instance, that like universal algebra tends to be a lot more popular in Eastern Europe than in other parts of the world, maybe. But you can probably find people doing pretty much whatever. Yeah. Yeah. So I do feel like this is kind of on this comment about how mathematicians from these countries is kind of on the line of like what is like maybe an appropriate thing to say in the chat. So like please try to I know maybe you were being hyperbolic or something like that, but please do try to avoid saying such things, because it's something that not everyone's going to be able to read the tone of your voice from the chat, and it can sound like pretty just because I want everyone to have fun, and I know I was talking a little bit of trash about like OpenAI and stuff, but like it's kind of different when you're saying like this is what people of a certain like ethnicity are like. It's not really but I will say the culture can be pretty competitive. I think in many ways the United States and Japan and Korea have some similarities academically that are not present in like Europe, for instance. not to say that everything's the same, but in some senses, you know, there are things that are culturally similar, especially about academia and the workplace in East Asia and the U.S. that are not as common in Europe, for sure. Yeah, universal algebra is about algebraic structures. Yeah, I understand, and there's also some nuance to saying, like, you know, if you're Japanese, then of course you can maybe say more about your own, you know, your own country and your own people and stuff. But I want to try to keep it, try to err on the side of caution when talking about, you know, such things. You know, uh, yeah, but I definitely understand. You know, I understand that you didn't mean anything really bad by it or anything. It's just, yeah, it's probably best to err on the side of caution. Um, but yeah, and hopefully someday I'll get to see Japan as well. But yeah, even Korea will be, you know, just going to Korea will be really cool. You know, and maybe eventually I can do more of East Asia when I have more money and more time. Um, let's see. So, okay, so I think I have this all organized. So the question now is, I need to, okay, well, first of all, I need to actually get this import working correctly. So it's not just called neural net and not discrete neural net. Let's see. Is it not called operation anymore? Oh, it's because it's in operations now. The naming scheme is getting better over time. Okay, so operation comes from operations. Oh, if I'm ever in an interview and someone's like, "What's your favorite Python package?" It's itertools. I love itertools. It's so good. It's just, you know, it does all the stuff that you want. You can make some nice n-dimensional kinds of structures to traverse and stuff, and it doesn't need to be the arithmetic ones that are like hard coded to have like those like float values from NumPy, which I still like NumPy, whatever. But you know, itertools, it's just good. It's wholesome, you know. Like iterators are nice, and I don't know. That's just or generators or whatever you want to call them. Okay, so this is all fine. I guess let's close the test for now. Component-wise is to a word. It's a word. Like, it's definitely, you know, this thing doesn't know. Component-wise is a word. Okay, so here is the neighbor function, and let's see. So this neighbor function is telling us what to switch to. Oh yeah, they don't like compound words. Oh yeah, you know, another thing that can be frustrating is that they'll sometimes, like, the spelling dictionaries will be like, oh no, you need to use a hyphen, or you can't use a hyphen because, like, they can't, people can't decide, like, whether there's a hyphen in the word. But, like, you know, whichever one you like to use, you're always going to find a dictionary that doesn't like your choice of whether to hyphenate the word or not. So yeah, that's just something we all have to live with. I really thought, you know, when I was younger, I kind of really felt like there was like a consistent, correct spelling of things, and then the older I got, the more I realized, like, people switch between like the like British and American versions of spellings of things all the time, and like nobody really notices, and like there's actually a pretty wide degree of inconsistency, and it's just it may be a hopeless endeavor to try to perfectly standardize it, because even with automated tools for helping us do it, we still can't do it. We still can't agree on how things are supposed to be spelled. So, but that's life, you know. Okay, so so in this neighbor function, I need to let's see, what do I need to do? So the twisting ones are the ones that are composed with endomorphisms, and then if I have a unary operation, well, I make a random choice of an endomorphism type. Okay. And if the arity is 2, then I make a random choice, and okay, I make a random choice, and then okay, this is hard coded. Okay, so this whole thing needs to be modified. This is from some old code that my student had from last year. A different student has now produced new code for this, and that needs to be changed. Okay, so over here, this is a definition of a graph class. This is a mutable graph, apparently. I kind of like to pretty this up a little bit. I mean, the code seems like it's perfectly fine, but well, okay, maybe I can make that a little bit simpler. I can probably just say if self.vertices. Yeah, okay, so maybe I'll clean this up a little bit, but it seems like a good graph class. Let's see. Okay, there's some nice stuff here. I'm going to need to write tests for this as well. Let's see, make tree file, okay. And then this is the actual polymorphism. Okay. So, I see. Okay. I see. I think that we actually already have Hemingway implemented. Okay, what are you complaining about now? Too many blank lines. Oh, there it is. Okay. Let's see. Somewhere here, I believe that the length of these things was defined. Why don't I just search for it? Comparison, the dot product, that uses the length. Oh yeah, they have a length function already. Okay, so I've already identified something that's redundant. This Hemingway method is just not necessary. Okay, so anywhere that Hemingway appears, I don't need to do that. Okay, that was it actually. That was the only place that it appeared, so that eliminated one thing. You know what's always funny about the people who I have not tried Techify on PyCharm, so I should see what that's like. Um, I will say I'm a little bit old school, and I'm generally apprehensive about putting, you know, doing any kind of like pretty markup like directly in the code itself. So like depending on like what it's like, I'm not sure, because I get squeamish about anything that looks like it might be, like, okay, like I don't have anything against Unicode. I'll say that to begin with, right? But like I when it comes to like actual source files for things, like I try to stay as close to plain text as possible, because it's the format that's most likely to be able to survive and be read in the long term. And so I aim for anything I write to remain as readable as possible. And so, one way to ensure that that happens deep into the future is to write things in formats that are extremely like traditional and stable. And so, my hope is that most of what I write will be able to be found in repositories in the distant future and actually be readable. So I will check it out, but I just want to say I get squeamish about anything that's putting any kind of like fancy decorations inside of the actual code itself. So I need to see what the actual source files look like. Yeah, but yeah, I'm definitely down to try new things though. Okay, so I want to mess the graph class at some point. I guess that's the first thing I'll do. I'll just proceed from the top. So okay, so I guess what I want. Why do I want the graph is mutable? Where am I actually using this? So okay, because I'm gonna perform this algorithm as I build it. Because I'm gonna make a random graph like that. Okay, because I want right. So I want a graph class. Just trying to think. Like I feel like a little bit hesitant about having this be mutable. And so where this is used is that let's see. I need to have the actual graph somewhere. Just look for it. Okay, so that's the constraint graph. It's a random tree. Okay, I don't actually need this to be mutable. I think I'm gonna make it. At least its attributes will be immutable. As I mentioned previously, making a truly immutable custom class is not really possible in Python, technically speaking. But it's at least I should make the attributes of this immutable. So okay, so the way that I'm going to accomplish this is okay, so this actually, okay, so I see. So the constructor of this was just written to have, okay, I see. Okay, and root is actually part of the, I see. Okay, why call it graph? Oh, because, well, okay, it doesn't have to be a tree. So where do I actually construct the minimum constraint graph somewhere here, or is this just, let's see. try to split this. I'm gonna try to split this apart. So first I'm gonna make classes for graphs and trees. So I'm gonna actually make a new file. I'll add it manually. I don't really like using the IDE to mess around with the Git repo for some reason. Like I know that it can. I know it's capable of it. I just like doing stuff in the command line. I don't know. Like it just makes me feel like I have more control over what's going on. I don't really know if that is true in any reasonable way, but that's just what I like. All right, so. This graph module is going to have graphs and trees. Let's just split this out as like a natural thing to do. Okay, here's the graph. All right. The beep sound effects are really important to make. If you don't beep at the computer periodically, then it won't know that you really care about it and want it to do well. It's part of the nature of these things. Okay, so first I'm gonna have a graph class that doesn't have this notion of root, and then I'm gonna have another class which is tree. Yeah, that's what I'm gonna do. I'm gonna have another class which is tree that is gonna have some other stuff in it. Okay, so I'm not gonna worry about the root. Root's a thing that trees have, not a thing that graphs have. The constructor is gonna look like this. So okay. All right. Vertex name is not there. Okay, I see. All right. Yeah, I'm gonna do this. I'm gonna do this in a different way. So this has methods for adding vertices and edges. I'm going to do this in a different way. Okay, so how are edges being stored here? Edges was a dictionary. Oh, I see. I see. Okay. All right. So when did they actually access? When did they actually access this? How are they using this? Okay. Okay, it's only used in that add edge method, I guess. That's the only place that it shows up. I see. Let's do edges. Alright, so yeah, I think I'm gonna make this immutable, get neighbors, return that. Okay, I see. So, yeah, I'm gonna do this a little bit differently. Let's see. The set root thing is gonna be, I'm gonna have trees have roots. So just make tree file, and then vertices, edges. I see. So this was just being stored as just a list of the vertices and then a list of the edges. Okay. So let's see, vertices. It looks, yeah, so it looks like the output of this make tree file is just giving me the list of vertices, and then the dictionary of edges. If that's a dictionary, it's just printing the whole dictionary, I guess. Which is fine, I suppose. But, I'm just not feeling great about that. I just kind of feel like it's storing a lot more than it needs to, and I think I'd like to do it differently. Okay, so I'm going to do something else instead. So first of all, it's not mutable, so maybe I should actually keep a copy of this here until I know for sure that I'm done with it. Alright, so I'm just going to keep a copy of that, but I'm going to comment it out. No, that's not what I want. I'm going to comment it out so that I don't have to deal with that. And then, let's see. Or I know that I'm going to be making changes to this. So, I want this to be immutable, so I'm not going to do that. I'm not going to do add edge. Alright, so I think what I'm going to do instead is, so graph, I'm going to do, a simple graph that is a set of vertices with unordered pairs of vertices as edges. And so vertices will be frozen set. Well, I guess, yeah, I'll just say frozen set. The vertices of the graph. And let's see. So there's vertices, here's edges, frozen set of, I'll just say pairs. Well, frozen set of frozen set, I guess. The unordered pairs of vertices constituting the edges, if I can spell edges correctly, of the graph. Okay. And so, well, this is kind of boilerplate, but whatever, it's still nice to do. Data graph. Okay. And so now, doing things this way means that if I want to have a method like get neighbors, then actually this is getting a little bit more interesting. So let me actually do this. I'm going to actually define define neighbors of a vertex to actually be something which is going to return an iterator, just because I feel like that's kind of a little bit more gentle. Okay, so then I'm going to, so I'm going to return, I guess, I guess I'll call it candidate. Candidate or candidate in self. How do I want to do this? Okay, so oh right, I can just make this thing itself. Okay. So no, because I actually want to return the generator. So okay. So I guess I'll say it. I guess I'll say it like this. Yeah, because I want this to be a function that returns the generator. Oh no. So I can say it like this. So edges containing vertex goes so edge or edge in okay, so then okay, so then what I want is I want to actually, so for each edge in the list of edges, if the vertex is in that edge, then I want to grab that vertex, or I want to grab that edge, and then okay, and then okay, so then neighboring vertices is going to be okay, so alright, so then what I'm going to want to do is I'm going to want to remove the vertex that is the one I'm interested in from each of the edges. And so how do I do this in a kinder way? Well, I guess one thing I can do is I can say I feel like there should be, I don't know if I want a one-line way of doing this, but let's see. Because like I can cast it to a list and I can delete the so of course it's possible to cast it to a list and then manipulate it, but I'm trying to think if there's a more like efficient like way of doing it that's using generators instead, because I don't want to have to cast all of the edges to lists, because doing that is going to make it more expensive. Like yeah, because I mean I could just make everything a list and then write an auxiliary function and it would be fine. But I want to try to do it in a way that's actually that's more efficient. So this is saying go through each of the edges, and if the vertex is in the edge, then we want to take that one. Now I have an iterator for the edges that are only the ones that contain that vertex. And so then I want to make another iterator that is just giving me the other vertex. And so like one way I can accomplish this is by using an auxiliary function. And I think that I do actually want to define that auxiliary function out here. I kind of wanted a one-line way of doing it, but I feel like it's not maybe the prettiest thing to do as a one-liner, so I'm just going to make an auxiliary function that helps me out. So I guess I'll do S and E for the set and the element. Drop element from pair, I guess I'll say. Why try to make it more general if it doesn't have to be? P for pair. Maybe I'll say take other element from pair. Well, I'll just say take other element. Why not? A pair of elements, one of which is meant to be E, and then E. Why not X? For X and P, if X is not E, return X. Okay. Oh, argument name should be lowercase. Alright, fine. I'll conform to this. So now we have our helper, and now actually neighboring vertices. Now I can actually, I don't even need to call it neighboring vertices. Okay, so what did I call this? Take other element. Take other element. And here's the pair. Vertex, and then I don't need to do this anymore. I can actually just return. Okay, great. Okay, good. So I do have to call this other function, but I don't think that this is going to cause me any problems, and I didn't have to cast anything to a mutable data type, so that's probably going to be a little bit more efficient as far as Python is concerned. Because I don't need to actually store all of that stuff. Okay, so that's what I subjected myself to because I decided to change the data structure here, but I think it'll be worth it. Okay, so I'm going to return this iterator. Alright, and so now I would actually like to, I should make a test. So I'm going to make another script. Test graphs. Alright, I'll add it manually. Just do everything manually. What else is currently in here? The string representation, this make tree file thing. Okay, I'll just comment this out until I'm ready for it. Okay. Yes, the formatting should be different. Do that. Okay. So import graphs. G equals graph of oh, to make my life easier, I need to do a convenience for myself that I haven't done yet. Yeah. So actually, what I'm going to do is I'm going to cast these. So if it wasn't already, then I'm going to have that these are immutable. That lets me be lazy and just write graph of the vertices will be A and B, and I have to specify a list of edges. There's an edge from A to B. Oh, maybe I'll make another ice. No, I'll do a path. I'll do a path as the first example. Okay. So there's an edge from A to B. There's an edge from C to B. The order doesn't matter. Okay. Blah blah blah. Oh. Alright, yes, do your formatting things, put spaces, whatever. I guess I'll do B. And I'll cast it to a tuple. Oh, yeah. Okay, I can be evil, but not that evil. So, yeah. Lists are not hashable. Let's put round braces on everyone. And remember, it's not the round braces that make it a tuple, it's the commas. And one of the, I mean, it makes sense when you think about it, but it's yeah. Okay, well, it works. Good. So that seems encouraging. So we have our neighbor function. Say construct an iterator through the neighbors of a vertex in the graph. Okay. So let's see our string representation. Okay. So this is the actual. This is if we call string on self, but I think usually I would do something a little bit more. I think I would use a different built-in function. So because there's the one that's the representation. I guess maybe I did it for the relation since I did that in a lot of detail. I guess I'm good on this for the moment. Let's see. So there's string, because I feel like there's a difference between there's two different levels of verbosity. There's let's see. Did I actually do an example of using both in this one? No. Okay. Well, let me just mess around with it, I guess. So there's this string, but there's also this, And so, hello. So if I just print G, okay, so that's gonna do the string representation, because it's just casting it to a string, I guess. But I feel like that other one was intended. I feel like this was intended for. Well, no, this is the documentation. Yeah, I feel like okay. I feel like I had separate uses for both of these things, but okay. I guess I'll maybe forget about that for the moment. But alright. So I would like to do this differently, perhaps, because this is just saying the vertices are this, the edges are this. I feel like I would do one that was like more verbose and one that was less verbose, and I'm trying to remember which was which. Oh, thank you. Yeah, that's what it is. And so, which one do I want to be more verbose? Print is probably supposed to be more information, and then just doing G itself should give me less information. It should just kind of tell me what it is. And so, for this one, I think I just want to do something like return you know a graph with some number of vertices and some number of edges. Well, things are happening on the internet apparently. Things are beeping at me. Okay, there's just a lot of stuff going on. Yeah, so let's see, a graph with that many vertices and that many edges. And so oh, well. Oh, I thought I was writing Python 2 for a minute. Oh, wow. I wonder if that'll keep happening to me every once in a while for the rest of all time. Okay. Well, in any case, yeah, I definitely thought you were right that that's what this representation function was supposed to be. Let me try one more thing. Because I remember I used to use one of these for the more verbose representation of the thing, and one for the less verbose one. Okay. So you're not supposed to have to call it like this. Yeah, so like that works correctly. Oh, I guess it's just if it's in the interactive. That's what it is. I guess it's just, yeah, oh, you're saying it right now. Yeah, it's just in interactive mode, not in the script. Yeah, alright. Well, that's fine. That's still what I want though. And then for this, let me just tweak this around a little bit. So maybe do a capital G graph with vertex set this and edge set this. And then if I got really fancy, I would even check to see how many edges there were, and I would choose whether or not I actually wanted to display all of them or just some of them, but that's it's not something I'm going to be doing today. Okay. I mean, it did cast it to a string. I wish there was just like a pretty display for, you know what, I'm going to leave it. I don't care enough. I wish there was a pretty display for sets in Python so that I didn't have to carry around the frozen set but could still have it be immutable. But I don't really want to add that in just to make this slightly prettier. Yeah, it's fine. Okay, no, I'm tempted now. Okay. If I cast it to a set, then what's it going to look like? It's not like I'm going to be calling this all the time anyway. No, it's too much nicer. I'm gonna do it. I understand why they want the default behavior to be. Oh, right. Yeah, that does actually remind me of another thing, which is that I want the edges to be set to okay, so this will be better, because now my edges are actually pairs. Okay, but then I need to actually I need to undo it if I want it to be pretty, so okay, that's what I get for wanting things to look nice. Okay. Yeah, and then I know it's too long. Yes. Are you gonna do it? Alright. What are you upset about? Overrides method in object. Well, yeah. What's the point of having the built-in methods if you can't override them? If I cast each of the edges to a set, then it should be hashable. No, because, that's ugly. Yeah, I see now. Alright. You know what? I'm giving this is too much work because I want it to. It made me realize something which was good, but this is too much work, and I don't want to have to mess around with that right now. It's just not worth the effort. Alright, whatever. That's a perfectly good representation. Now how is the file being written? It was just the vertices and then the dictionary of edges. So I guess I also would like to change the directory structure in here a little bit. So I should look at what I was doing when I was reading from these things. So with that is read file, then I was using JSON.loads. This is the way that I want to do this. Alright, well, it's getting to be about that time, so at least I have finally decided how I'm going to rewrite this data structure a little bit for the graphs, and I should be on my way to starting to redo this. Thanks for chatting with me so much over the time here. Thanks also for trying out the new 3-hole donut. I'm really glad that we were able to do that. And I had fun live coding, for the first time. I've never done this before. It was pretty cool. I got some really, nice feedback from everyone. I, got to talk about various, dramas related to, neural nets and machine learning and other such things. It was cool. Yeah, so I'm not sure yet what I'm doing next time. I definitely appreciate the suggestion that I try just looking at random papers that people bring me. If I decide to do something like that, I'll definitely post about it on Mastodon. So make sure to check out what I have going on there from time to time if you don't already. Are there any last questions that people want to ask, or things that anyone wants to say, or anything? Yeah, it's I guess maybe just to end, I'll just say, this has been cool. I keep having new experiences every time doing this, and it's continuing to be a lot of fun. It's always really wild to go from the reality of oh yeah, we do need a Dobby emote for sure, absolutely. Yeah, I should get on that. I'm not sure what copyright implications the name might have. So maybe we'll just have to call it like dog generically, but then you know that it's our dog whose name is Dobby. Yeah, we should definitely have a Dobby emote for you. That would be really helpful. Yeah, I keep learning new things doing this. It's really funny actually to go from the discussion of the big picture politics and stuff related to artificial intelligence to actually doing the details of doing the coding and everything, because it's at the end of the day, it's there's such a big gap between the hype that people have and the sales and the marketing and everything, and then the reality of it takes time to write code to do a new thing. It's still pretty hard to automate it, to do something that's non-trivial that hasn't been done before, and you really can see the reality of the sales pitch grinding up against the real world, and how math, I don't care how good you are. I know people were talking about how competitive it is getting a postdoc different places or whatever, and there's no one in the world who really is just writing 100 lines of great code a minute or something crazy like that. Math and coding always is kind of it's very methodical, and you spend a lot more time thinking about each line than you do actually typing the thing out. I don't know. I obviously hope for better forms of automation in the future. I wouldn't be working on things related to artificial intelligence if I didn't. But at the same time, there's still a lot left for human beings to do. And I've been having a lot of fun doing it. So hopefully, you can follow this on GitHub. If you start the repository, you can keep following it. And hopefully by later this summer, we'll have some more cool examples for you. Things will work better. And yeah, it should be pretty cool. I really appreciate everyone, as always. I appreciate your support. Doing the emojis and everything. It's really fun. Yeah, so it's it's been a really great time, as always, and I'm really looking forward to seeing everyone next week at the same time. It's gonna be really cool. I have no idea what I'm gonna do yet, but I'm sure it's gonna be a lot of fun. So yeah, if there's no like last minute questions or anything, oh yeah, Mondays. Yeah, that's I should get on trademarking that. I should really file for that to be a trademark. Mondays is definitely a really good consonant cluster, and I appreciate you being here for it and giving me all the awesome suggestions. Yeah, it looks like it's time for me to head out, but just thank you all so much again. It's been really cool, and I look forward to whatever we get up to next week. So make sure to have an awesome week. All right, see ya.